Welcome to Analyst Crossfire, an ISC 2013 wrap-up show featuring expert voices from the international supercomputing community giving their reactions to some of the top HPC trends as discussed at this year's conference. I'm Addison Snell with ISC13 Research, and I'm your moderator for Analyst Crossfire. Joining me on the panel today are two vendors and two users who have volunteered to play the analyst by sharing their opinions on current and future supercomputing trends, giving us their personal views and not necessarily those of their organizations. Representing the vendor community, first we have Marie-Christine Soli, who's the Paris Exascale Lab Director at Intel. Hi, Marie-Christine. Next we have Naoya Tamura. Tamura-san heads up the Global HPC Office for Fujitsu. Tamura-san, thanks for joining us. Representing the supercomputing user community, we have two internationally recognized, highly esteemed representatives of prestigious HPC sites, including our first two-time Crossfire panelist, Satoshi Matsuoka from the Tokyo Institute of Technology. Welcome back, Satoshi. And finally, from the International Center for Earth Simulation and formerly the CEO of SGI, my friend Bob Bishop. Bob, I'm so glad to have you here. Panelists, thank you all for joining me for ISC Analyst Crossfire for 2013. Clock's running. Let's get started. Our first topic today looks at the potential role for ARM in HPC. Processor architectures are one of the hot topics in the industry right now. What do you see as the future of ARM in HPC? Are there segments where you think it will become established, Tamura? Tamura, anywhere that ARM will become established?
We do not see the big problem for the processor specification of ARM. So more important point is how you implement the processors and also the economic effect because of the volume of the processors, the shipment, etc. And from our viewpoint, that HPC processor selection might be some kind of the follow-up for the more commercial and volume product line. So the ARM is significantly increasing, actually, the volume shipping. So therefore, there is quite positive things exist there. This is our view.
Marie-Christine, you might have a slightly biased opinion coming from Intel, but I'm nevertheless very interested in your perspective on ARM in HPC, where it might get adopted.
Well, I think this conference has shown that HPC is actually moving to include even more use cases than we've ever seen before. And what I can witness is that in this broadening of the use cases, certainly the computing platform play a very big role. But in order to cater also to many needs, many of these needs, the continuity between the different platforms for the software continuity and programming model continuity is going to play a very big role, key role, maybe more than we've seen before. So I would be very interested in following the developments in that respect and to see what happens specifically for this solution.
Yeah, we just had a very excellent presentation earlier today from John Goodacre of ARM. You've heard the vendor community talking on this. Satoshi, what are your thoughts here on ARM and HPC? Where does it belong?
Well, you know, what many people have misconceptions about is ARM is like embedded processor in cell phone space. Actually, there's no, as Tamura-san said, there's no architectural restriction. In fact, now the server-based ARM is becoming quite a force in, for example, the communication market. And they have all the resiliency features of any, like a server processor.
That we shouldn't be thinking of it as a cell phone or an iPad processor.
Not at all. And moreover, of course, there's a 20, but then we think of it as a cell phone system, there's a 2 billion processors for your ecosystem. So the software tools, everything, certainly will, with the parallel execution being more a norm in those embedded space as well, you're going to have a huge ecosystem software as well. So it's going to be very significant.
But you and Bob next to you, and I'll get to you, Bob, in a second, you both represent mixed workload environments. I mean, are there particular application areas, Satoshi, where you think it's more or less likely to get adopted?
To me, if ARM becomes as fast as, say, Intel Xeon processors, or even less but more power efficiency and cost dependent, I see no impediment to adopting it over Intel, if I excuse my expression. You know, it's just as good a processor as it would be Xeon.
You said something important there, though, that there's not an impediment as long as it gets price performance close enough. Bob, you've been very patient. Let's get down to you there, ARM and HPC.
Well, it makes sense to use ARM in application-specific situations where it can be optimized and focused. The low power consumption issues are going to help ARM take high-performance computing into the mobile environment. For example, oil and gas discovery, companies like Schlumberger and Halliburton are out there with trucks and putting a lot of signal processing right next to the sensors is going to be a very sensible thing to do. So ARM is going to supply, I think, the machines to help that happen. Any vehicle, any mobile application, including space travel.
I guess so space travel you just finally hit on. We keep hearing application-specific areas, and I'm probing for what are the specific applications implied by application-specific.
Well, International Space Station, for example, or any kind of satellite where you want to do a vast amount of processing.
It's not a very large target market, though.
Well, that's true, too. You may have
Station.
specialized niche markets. I think so.
Back to the vendor side. Any thoughts on this, Marie-Christine? I'll get you Satoshi.
No, I think we definitely the ecosystem is going to play a big role. I mean, with the partners, for example, that we are engaged, academic research centers, we can see that from the community emerging that there is a good concern, because it's motivating to develop this ecosystem. So I'm really looking forward to see these two things moving along. Again, the use cases are broadening for HPC, and let's see what comes out.
Satoshi, I cut you off there. Go quickly.
I completely disagree, because look at BlueGene. Is it using x86? Look at K Computer. Is it using x86?
No.
No, but it's...
Did I get that one right?
Yeah, so
okay.
Is it any different from ARM if they perform similarly?
Spark is different from ARM, yes.
But in terms of performance.
Okay.
Implications, especially in server space and in evolutions of ARM, which, of course, like Fine Micro, they're working on. And they will be just as performant in terms of power efficiency. So there's just no reason, if you have the same reliability and equivalent or better power performance, that they'll be adopted. For example, you could replace all the Power PCs in BlueGene with ARM, and you'll be happy.
Tamura-san, I want to come back to you on this and ask a slightly different question. Is with all these different processor architectures that are part of the discussion, what's the determining factor that will decide which of these processor architectures start to win out? Take your microphone.
From my viewpoint, today that processor architectures it's not becoming significant difference. For example, like adjustment of the power consumption depending on the power, clock frequency, it really depends what is the sweet spot to choose that. So the dependency on the processor architecture is becoming a little bit less. This is our opinion.
Becoming less dependent on what the processor architecture is. That's why you have so many choices. Panelists, thank you very much for your views on ARM and HPC. Let's move to the next issue. Independent software vendors providing HPC applications are typically not large companies, and yet they're faced with a lot of important changes and challenges in the market. They get demands around multi-core, many-core accelerators of different types, cloud computing, persistent drive for greater scalability, plus, of course, everyone wants their bugs fixed. If you were running one of these companies in the HPC space, what would your priorities be, Marie-Christine?
My priority would be to get back to one of the exit of the courses, the outcome of courses in HPC that happens in the universities. There are excellent courses out there. And if I was at the head of one of these ISV vendors, I would try also to engage in some of the programs that are especially here to help redesign some critical part of the HPC software stack. And I think to engage into this sort of tripartite agreement. Not all ISV are aware. There are very rich programs coming out in that respect. And I think there should be a way to leverage from this capacity really to move forward and recruit these new talents, brilliant new talents that are coming out from such...
Went off book, off the slide, re-engagement with the academic community is your top priority. Tamura, how are you going to do it?
It's a tricky question, actually, because there's a big dependency on application algorithm way to parallelize the code. For example, like a suitability to the Xeon architecture, GPU, etc., has a big dependency depending on how the application has been designed very long time ago. Most of the applications ISVs has been designed long time ago. So adjustment of the code is not so straightforward. Regarding to the cloud model is not very suited to the ISVs again, because the existing license model is much more beneficial for the ISVs, but they are forced to go to the cloud anyway sometimes.
Okay, but you're restating the problem. You're saying, yes, accelerators are hard, cloud is hard, people are asking for them, what are you going to do?
That's a very difficult question.
Yeah,
I think
that's why I
they need to
brought it
find
up.
out they need to find out the most appropriate compromisation from lot of different kinds of difficulties. This is my view.
Okay, down at the end, the user community, you've got to buy these applications. Bob, what do you think they ought to be focusing on from a business perspective?
Well, I think what's going to happen here is that if you co-design, which is the phrase that we use in IHPC business right now, the more you co-design, the more you tightly couple the application with the hardware, and it makes it less portable. I think that's the fundamental trade-off that's happening. If you look at companies like Oracle and figure out how they handled the plethora of underlying processes, they dumped them. They chose the top three and dumped everyone else. So this is one way of surviving for a small ISV company.
Oh, that was one of the arguments from MPI when we all started going that way, was portability, that it could be the same on every platform.
I think that's what's going to happen. I think the smaller ISVs are not going to be, even the large ones won't be able to support all the possible hardware configurations that are out there, and they will prioritize and dump cut the tail.
Okay, so, but again, you're kind of restating my question, is that it needs to be prioritized. Do you have a
Right.
sense of what you would keep and what you would dump?
Well, what the ISV normally does is select those that give the volume, and those chips that don't, or those architectures that don't support the volume, they're gone.
Satoshi, you got a definitive answer there for me?
Well, so I'm not so much in disagreement on this point, but I guess the question depends on whether you are a new kid on the block by being small, whether you're new or old, established. I think the strategy will be very different depending on whether you're new or old. So if you're old, then you try to lock the market.
Right.
And then that could be done by, for example, university participation, because nowadays, for example, on our machine, we let every undergraduate use it. So by having an ISV code, so it's a computational chemistry class, then you'll be nowadays students will be using these very ISV, very friendly, user-friendly code.
How do you think this continues to evolve? Does this substantially change what it looks like?
Yeah. So then there's always a disruption. So if I were a new ISV, then I would try to change that by adapting to brilliant new architectures such that I get this really definitive win. But of course, being very selective about it. So it's really whether the business model is either lock-in or try to disrupt the lock-in by being excellent.
I want to come back down to the vendor community in the sense that it's a business question, right? I think one of the challenges is no one wants to pay more for software. And a lot of this comes across as, let me give you a new idea for a business model where I don't have to pay you as much. Do we need a new business model here for the ISVs, Tamura?
It is definitively yes, and it is necessary to bring some new business model. But also that existing model of the ISV will be continued because of some lot of regulations, for example, in the industries, like automotive industry. They cannot go to the open source. They have to stay with the existing ISV, mainly because of the regulation limitation, etc.
Marie-Christine, quickly back to you.
Definitely a new business model is needed, but just to find out exactly how to handle that, I think in the co-design area, it's really important that the ISV gets close to the people that are developing the architecture and the new talent, as we said before, and really in a few months, on a short period, try really to break these barriers and try to learn and then reintegrate whatever they will learn or find out in this sort of program.
Yeah, I mean, our research would show certainly they have constrained resources a lot of the time, and as they have to prioritize this, bug fix winds up always on the top of the list, and when you get something like cloud, the ISVs we're talking to are saying, yeah, we're offering it, but we still don't expect it to be a major revenue source for us. That traditional licensing winds up being the bulk of the way that they do business going forward. All right, next topic. Part of being an analyst is not being afraid to represent a minority opinion when you think it's appropriate, where you're disagreeing with the other very smart people around you, which can be kind of scary. From each of you, I'm wondering, do you have a minority opinion in HPC, some topic where you think the majority of the HPC industry is maybe not on the right track, Bob?
Yeah, I do. I think the HPC, and especially the roadmap to exascale right now, looks very much like kind of the old glass room kind of batch processing model. I believe it should be far more interactive, immersive, with the scientist in the loop, so that the scientist can computationally steer the process and see what's going right and what's going wrong, tune the parameters that are in the model, and actually write it. And by doing so, eliminate many computational cycles that are going to be otherwise created. And so this kind of real-time, in-the-loop, optimized, and there's a lot of analytical equipment, tools, software tools that can be deployed at the same time. I would like to see the HPC environment move in that direction rather than just optimized around a single
Get
impact benchmark.
application scientists into the loop for better exascale development, better tools for programming.
Yes.
Satoshi.
Okay, so my minority view is not so much within HPC, but I think it's amongst the HPC industry. And my current assessment is that big data will be subsumed by supercomputing.
Big data will be subsumed by supercomputing.
And let me tell you the very short version of the reason why. Okay, the growth of HPC and performance is 100% per year, according to Hans and Limpak. Whereas every data I've looked at, big data cloud, and also cloud, only has a growth rate, and network, and also wide area networking only has a growth rate of 30 to 40% per year. So how can a industry that has 30 to 40% growth a year subsume HPC? It's the other way around. HPC shall win.
HPC wins out overall. Tamura, minority opinion for you.
So one of the minority opinion is the HPC will not become the mainstream. Our cloud might not become the mainstream for the HPC, mainly because of the very big data movement and a very strict critical data security issue, and also some kind of a trading barrier across the countries. So therefore, there's a lot of people is thinking that, okay, that HPC is going towards cloud. But the minority report is the cloud might not be the mainstream of cloud.
This is one I'll spend a moment on because your minority view and ours are the same on this, but just because you and I agree doesn't mean we aren't in the minority. Our research has found that spending on cloud is a small portion of the market, but it's not growing any faster than the market as a whole. Utility computing has been around in this industry for a long time and will continue to be, but we don't see cloud overtaking HPC. It's an important part of it, but only a small segment. Marie-Christine, your turn.
My minority view on that is the following. I'm going back to the big data, but from a different angle. I disagree when we say that the most interesting challenges about big data may be biology or cosmology. They are. But we may have as a community, as an industry around HPC, big data that are actually all the data collected and the data that we observe from the running of the machine, from the running of the workloads. So if we engage with the centers, with some community of users, and with ourselves who are building the machines and developing the machines, collect this data and analyze it in a very schematic, in a very precise way, we may be able to extract some very interesting decision tools just to help us to move up the scale. And I'm not sure that we gave enough attention to that as a community.
See, this is wonderful because this question is designed to get people shaking their heads at each other. Satoshi, you heard about this re-engagement with the industry, both from Bob on the exascale side and Marie-Christine on tools and big data. What do you think about these views here?
It's all about the talk of convergence. Conversion of the big data and HPC. And my claim is that the conversion will happen in a way such that HPC will be subsuming big data technologies. I mean, it's not so much a market, but the technology, there will be a subsumption
right.
of the technologies. And but of course, it's not automatic because some of the requirements are different. And so the HPC may have to be diverged a little bit, both in terms of architectural and more importantly in the software side, to accommodate for the needs of the big data.
Bob, last words yours on this topic if you want it.
Well, the problem with cloud is latency. So if an HPC job is sufficiently embarrassingly parallel, you can use the cloud. But if you need tight coupling between the software elements, then I think the latency in the cloud is mission impossible.
I disagree with you there only in that you said the challenge with cloud and HPC is
Okay.
latency. What we find is that latency is the head of a long list of challenges with respect to cloud, and just addressing the one might not get you all the way there. But that was the point, is that we're supposed to disagree on that one. Thank you for your in-depth insights. That was the long answer format. I hope you enjoyed it. We're now entering the speed round. Finding skilled HPC people is often cited as a challenge for your own organizations. Who would you most like to add to your own team if you could? And feel free to either pick someone you've already got and start cloning them, or play Dr. Frankenstein and put together somebody new. Satoshi, your turn to go first.
I would employ a genesis so I can make many clones.
I'm sorry?
I will find a capable biologist so I can make many clones of capable people.
Well, okay, but what sort of person are you trying to hire here? You can't just say, I'm going to start cloning everybody.
The people who we value are people who really have the qualitative sense of the very quantitative metrics of both the machines and the applications on both sides. So because it's so important in HPC to work on the quantitative aspects,
Yep.
and those are sometimes very lacking in both.
Bob, who do you want to try to hire?
Well, I would choose a numerical analyst, because I think the application has to be pulled apart, and every cycle in the app, every code line in the app has got to be understood and possibly rewritten. And even the underlying science, which drives the algorithm, may have to be revised, because so many of the apps are now quite old, and they embody old science. So I think we've got to tease the app apart and carefully put it back together again, possibly with new science, new algorithms, and of course, software engineering.
Marie-Christine, Intel's got a lot of open recs. Who do you want to hire?
I would hire a computational astrophysicist because of the capacity that he or she has taken into modeling lots of different things that can be implemented into a whole range of science. A person that would also be interested in making very precise calculation or helping very, very precise calculation, and has a good interest and understanding about what the architecture is underneath.
Computational astrophysicist Tamura, you get to hire someone. I hope everyone brought their resumes. Go.
I would like to employ the person who go to the HPC customers, immediately understand the pain point of the customers. Because today, for example, like a weather forecasting, sometimes data assimilation is more critical than the deterministic part of the forecasting.
Someone
Automotive
customer
companies-
focused who
Yeah.
can understand the pain points. Keep the mic. Next topic. What currently underappreciated technology is not getting enough attention that we should be looking out before by the end of the decade, Tamura?
It might not be exactly answer, but deterministic, the multidisciplinary science, multidisciplinary engineering, and this is really important for the another 10 years. How you look at the multidisciplinary scientist engineering. Yes, this is the key.
Multi-physics. Marie-Christine.
I think we don't give enough attention of the tools and things that we need really to provide to the community that, as we heard during this conference, is more interested into outcome than outputs.
We start coming back to the show by the end of the decade. Tools are the hero technology. Bob.
I think remote visualization is the missing technology. If we really want to use these HPC centers well, we're going to have all our remote scientists and engineers kind of fully plugged in to the simulations as they transpire.
Watch out for remote visualization. Coming on strong, Satoshi.
Well, there are a lot of important technologies, but probably most underappreciated is the software engineering technologies.
I'm sorry, which technology?
Software engineering.
Software engineering.
Yes, because so many codes are big, complex, many facets, just as the previous keynote, and just we need people to develop new, even better methodologies to handle these types of complexities in software.
Final speed round question. We had a new impressive #1 system this year. It's 2013. It's time to make an official, on-the-record, on-camera prediction about exascale. Where I'm going to ask you about when we're going to have the first sustained exaflop LinPack top 500 system. First of all, going down the table, what year is that going to happen in, Bob?
2022.
2022. Satoshi.
I say 2020, so bold statement.
2020. Tamura, do you need to defend that? You got 5 seconds to defend it if you want.
Because we went factor 32 in 5 years, so another 32 in 5 years.
2020. Tamura.
I agree, 2020.
2020. Marie-Christine.
2020.
I'm on 2020. Bob, you're last. We're going to see if you're right. What country is that going to be in? We'll go the other way, Marie-Christine. Who gets it first? Which country?
It will be in Asia.
That's a continent. Can you be more specific?
No.
No. Okay, Tamura.
I would like to say Japan.
Japan. Satoshi.
I think it's going to be China.
China. I'm hearing that answer a bunch. Bob.
Israel.
Israel. I'm going to take Japan, but China's a respectable answer. What processor technology will it use? Marie-Christine, I'm doing you last. Bob.
MIPS.
We're going exaflop MIPS in Israel. You're opting out of this question. Satoshi?
Well, ISA doesn't matter anymore.
Doesn't matter anymore, but really, what's it going to be?
Likely extremely high-throughput stream computing processors like GPUs and mics.
Tomorrow, what's it going to be? Oh, so GPU you went with. Okay.
I think it's not so very important, but the processors which is very good for the power consumption, density, and reliability.
Are you going to say Spark or Intel Xeon Phi?
It's very unpredictable.
Yeah, but that's the point, is you're supposed to make a prediction. Marie-Christine.
Is my answer predictable?
Yeah, you're going to go in. Well, I don't know if you're going to say Xeon Phi, Xeon, or
It will
Atom.
be a successor of the series between Atom and Core Xeon Phi that has more integrated capacity with the fabric and the data.
Finally, how much power is that system going to draw total? Tamura.
20.
20 megawatts. Satoshi.
I would like to say 20, but my projection says something like 25.
25. Bob.
15.
15 megawatts. Marie-Christine.
22.
22. I'm going to go away from the rest of you. I'm going to say undisclosed, but it'll be on the order of 100 megawatts. All right, thank you, panelists. We're going to wrap up Analyst Crossfire with our final traditional question around the table, one up, one down. We're at the end of the full ISC 2013 show now. I'd like to hear from each of you one positive surprise and one thing you expected more from over the course of this conference. Bob.
Well, positive surprises, of course, China, the system. Number one, it was great effort from China. I think the negative was just getting to Leipzig. You know, that was a hard thing to do and expensive.
You know, Leipzig's a beautiful city here. We're going to be enjoying it next year. Go ahead, Satoshi.
Well, my positive surprise...
I heard, by the way, your travel story, Bob. That's not Leipzig's fault.
It's the airline.
Well, it's not just China. My positive surprise, well, I wouldn't say surprise, but my happy expectation come true was really, road to exascale seems to be accelerated because there was some, downturn for a moment, but now it seems to be really vibrant. And then the bad part is, I'm confined. This is my 7th appearance on stage, and because I'm so occupied, I can't really see the city, this beautiful city.
Excellent city. Okay, Tamura.
I think one up is Intel. Intel is everywhere, and that's amazing. And one down is the HPC solutions. There is not a lot of new HPC solutions has been seen. It's just a bit and pieces technologies.
Here's a brave answer coming. He's actually going on record. I agree with you. Intel had a very good show, not only with the new #1 system, the Xeon Phi roadmap. They launched a Luster solution last week for Enterprise Edition. There were a lot of good Intel news, and disappointment in the solutions, I think, is another nice choice. Marie-Christine.
So for me, the positive sign is to see such a challenging project as the human brain now really driving the most interesting development in our community. This for me really is something that is very comforting because it drives really, the expectations are very high and we can feel that there is a commitment from the European partners. I think this is great for Europe. On the downside, I would say that I was in the industrial track sessions, and I feel that the losers are those that didn't follow those sessions, because there was a lot of very interesting developments, use case being shared, and it really needs to be interesting a lot more people.
ISC did an excellent job bolstering the technical content this year. There were a lot of fantastic presentations throughout. For me, myself, the only thing I really had trouble with was the heat, and you can't blame the conference for the weather, but you all chose great wardrobe for this. I'm dying in my suit. The winner was the nice cold beer. The loser was the air conditioning. Panelists, that concludes ISC Analyst Crossfire, and with it the 2013 ISC Conference. I'd like to again thank my panelists, Satoshi Matsuoka, Marie-Christine Solly, Bob Bishop, Tamura-san, for joining me and sharing their insights, as well as Hans and Martin Moyer and the rest of the very excellent ISC team for another successful ISC Conference in beautiful Leipzig, Germany. For Analyst Crossfire, I'm Addison Snell with Intersect 360 Research. Thank you.